basically just a daemon that instruments the nDPI and does some other stuff, like basically doing all the flow stuff. Like you need to, for example, you need to differentiate between, or you need like at least have like kind of a some information to say, hey, those packets are belong to a flow and those not. This is like some of the things that the daemon does, which nDPI basically does not by itself. So the idea was to provide kind of a really small, minimalistic version of ntop. But this is not true because it just fulfills a small subset of what ntopNG does. So that's why I put it in. It's because it's not basically ntopNG just much more than it. But it was designed to run on embedded systems like small OpenWRT routers, and the idea was to basically have the packet capturing and the DPI on the same machine. So this works pretty well on like small networks. It won't. I mean, I'm just testing it on a bigger network, but it's not pretty well tested. So I'm usually testing it on like small networks, like just 10 or 20 of computers in there. So the idea is that you basically have the nDPI daemon, which processes the network data and sends out the detection data to custom applications that can connect via TCP or via Unix sockets. It's kind of it's not the same, but it's kind of a microservice architecture. So you write small daemons, usually in C or like in Python, and those daemons are connecting to the nDPI serve daemon, which I will tell you later what it is. It's like split it in two applications or two daemons. Like the first one is the nDPI daemon, and the second one is the serve daemon, which basically collects the data, the detection data that's coming from nDPI daemon to the serve daemon. And yeah, your application can connect via TCP to process the JSON data. So it relies on the nDPI, as I said before. It makes heavy use of its API, and for example, I need all the tree-based flow pointer storage, all the layer 3, layer 4, layer 7 protocol dissectors, and of course the analyze API, which is pretty useful if you want to like train an AI. So for machine learning, it's basically really useful because basically you have like a pre-normalization and a pre-processing of the data that you want to use to train your AI. And it already provides a serialization interface, so it makes it pretty easy for me to have basically everything together that I need. So how is the architecture? It's an event-based architecture that uses it's really a simple kind of JSON protocol. I will give you some more information about that later on, but there's nothing special about that. So it was designed to be stateless, so your custom application can connect at any point, at any time to the nDPI serve daemon to get the current flows which are active on the network and doing stuff. So it supports two modes of operation or transmitting events. So the one I'm showing you is the Unix-based socket connect and send, which means nDPI daemon connects via a Unix socket to the nDPI serve daemon, which then distributes it to all the custom applications that you are interested in. The second one is currently tested by Damiano Gassoli. He's not here, unfortunately, but he helped me a lot testing this in a bigger environment. He also has like access to like bigger networks, and yeah, I really needed that to have like a bigger test infrastructure for the daemon. But I only will focus on the first one. This is like a really simplified processing pipeline. So basically, in this example, you have two daemons running on two different network interfaces, as you can see, and they are both of them. They are basically using nDPI to get the detection data, serializing it to a JSON string, and then sending it via the Unix socket to the nDPI serve daemon. So, and the daemon consists of like two components, and there are more components, but the most important ones are the collector and the distributor. And then you can use the custom applications for visualization. You can use the flow analyze daemon, which is also like kind of a microservice, which extracts some of the analyzed data that is basically created by nDPI and then can be used for machine learning purposes. And also the component, the flow analyze component, is also able to emit logging events to syslog, for example, which can be really useful. And also dump pcaps, which pretty made my work with nDPI much easier, because now I have like the ability to dump pcaps to disk on every device, on every embedded device, and I can use those pcaps. For example, they are not detected, they are only guessed, or they have some risk set. I can use those pcaps to further improve nDPI. So that is my current workflow. When I get some undetected flows, I usually use the dumped pcap that was dumped by this custom application and use that to improve nDPI's detection. Okay. So let's talk about the self-written custom JSON protocol. It's pretty straightforward and there's nothing special about it, as I said before. So all the communication between every single instance or every single daemon or application happens by this simple protocol. It's used by nDPI daemon, by the serve daemon, and by all custom applications. Because the goal was, it needs to be, all exchange data needs to be human readable and also machine readable, so that was basically the reason why I decided to stay with JSON. And as you can see, you have just a 5 bytes encoded string length. This describes the length of the JSON string itself, including the new line terminator. So this is just for performance reason, because otherwise I would basically look up for the \n, and I just thought it might be just for performance reasons. Because for the deserialization, I don't use nDPI, I use a third-party library, and the library is not at best for deserializing JSON strings which don't have where the size is not known at the time when you're trying to deserialize it. So it's basically just the 5-digit length encoded as a string, which describes the length of the JSON string and the new line terminator at the end. And so nDPI daemon uses kind of an event-based system. So you have various events describing what's going on your network. So the first category are daemon events, which are only related to the nDPI daemon itself. The init reconnect or shutdown event, so that when the daemon initializes or starts, it emits an init event and it reconnects, because sometimes there might be some issues with the socket. For example, if you just by accident you remove the socket, you need to basically nDPI daemon needs to be able to reconnect at a later time when the socket is available again. Then you have a shutdown event. Obviously, when the daemon shutdowns, it tells all applications they are going down. And the status event, which basically gives you oversight about processed flows, the memory that is currently in use, the memory that was totally in use, the compressions. For example, it supports dynamic compression of long-lasting flows, which are they are long-lasting, but they don't do anything. So, but they're active. And to save memory, nDPI daemon uses clip to compress those flow memory and to save some memory. And this is also reported in the status event. And then you have the error events. Basically, all with 2 exceptions are errors that are coming from libnDPI itself. Only events like a memory allocation failed, for example, a dynamic memory allocation failed. Then there will be like an event emitted if something is wrong, maybe you need more memory and stuff like that. So, but all the other errors are coming from nDPI itself. Then you have there's some typo I just saw. Packet events, so they have 2 sub-events, packet flow, and this is wrong. It should be like, instead of init, there should be like packet. Probably a copy and paste error. So you have like packet flow events, which make, so when you receive a packet flow event, it means that the packet data that you're receiving, encoded as base64 data, belongs to a flow. But sometimes you have just, for example, it happens sometimes that nDPI was not able to process this flow for whatever reasons, and then I'm not able to say it's like a flow that belongs to an already existing flow, or hey, it's a new flow. So I treat this just as packet data. It doesn't belong to any flow because nDPI could not give me any information that I need. And last but not least, there's the flow event itself, which is the most complex thing, because most of the stuff that we are basically interested in is happening there. So that's why I put it on the next slide, the whole definition of the flow event. This was also done by Damiano Vasili, and great thanks to him. And it looks more complex than it actually is. So we basically, every flow starts with a new event. New means the 5 tuple that I just got, I did not have it in any of my trees. So it's the IP address and the source port and destination port together with the layer 4 protocol is completely new for me. So I say, hey, it's a new flow. And yeah, with that information, so after the first packet was received or processed, it goes further to, depending on what nDPI does, it can be emit a detected event, which means nDPI detected it with some detection data. Basically, all the data of the nDPI flow struct, which gets serialized, is available in that event. It can say a not detected event, which means nDPI was not able to detect the flow in a certain amount of packets that were received. So this is like configurable. You can, for example, tell nDPI or the daemon, hey, I just want to have 15 packets. The first 15 packets need to be enough to either successfully classify the flow or not. So, and then you have the guessed event. Of course, this is like tied also to nDPI. So sometimes, I'm not happy with this guessed mechanic, but I'm using it anyway. Which means that nDPI has some certain like heuristics, so to say. If nDPI was not able to detect any layer 7 protocol, it falls back to like port-based detection. It's not good, but I'm using it because it's already there. And let's go to the right side to the detection update. The detection update happens all the time. So my approach is to give as much as possible information as soon as possible. But sometimes it may happen that nDPI detected, for example, after the first packet, it's a layer 7 flow, a protocol that I know. But like, for example, after the third packet, it says, I have new information available. The issue is that nDPI is not able to, there's no API function in nDPI that can you use as a developer to ask nDPI, hey, do you have new detection data available? There's no such function. So my approach was to build a hash over the whole nDPI flow struct, and not over the whole, but over the parts that are changing often after detection updates happened, or after nDPI was able to dissect more data. And so I'm using those parts which are basically more stable and build a hash over those parts. And if the hash changed, I'm emitting a detection update and basically again serializing the whole flow struct. So this is most important actually, because for example for PIC or for TLS sometimes the first packet you get does not contain, for example, the SNI. Sometimes you need to wait for the second or the third packet if you get the SNI, which is for me is most of the important things to have an SNI, which you can work on. And the update and analyze events, they are those are not related to this kind of cycle, because the update event is only there to inform, for example, a flow that is like long lasting, that lasts over like hours or sometimes days, to inform applications, custom applications, hey, there's a flow, I detected it, or maybe I detected it not, but here's some information about the flow. And there are analyze events, and the analyze events are basically only useful if you want to like train an AI or use machine learning, because they contain the preprocessed data, which are parts, preprocessed data from nDPI. For example, you can use data bidding, which is already part of the library, the core library itself, and this is really useful for machine learning and also other stuff. And last but not least, the two more or less important events is the idle event, which means in a certain amount of time I did not receive any packet, so I'm emitting an idle event. So it means the flow is idle. Or the end event, which actually I'm not sure if I will remove it in the future, because it only happens for TCP, and even there TCP/FIN or RST is like a special thing. It does not necessarily lead to a flow end, because even after you received TCP/FIN or RST, there can still be some data on the wire. And this is something actually, so I don't want to like miss out some data. That's why I probably will remove the end event, because it's only relevant for TCP anyway. So now we're still having some time, I guess. Okay. Let me show you like a really interesting thing. So this, I hope you can.
Yeah.
Oh yeah, no, that's that was not good. So this is like a live environment. It's basically a really small network. I asked all the people that are using the network if it's okay to show that here, so there's no privacy concerns. So this is basically live traffic you can see on the small network using the nDPId. And so it's just a Python script that instruments the like kind of a helper script that I wrote that just decodes the JSON protocol and decodes the JSON string and it puts all together and gives it like some pretty output. You can also like use some filters, for example. Most of the time, I'm only interested in events where the risk is set, so to see if this makes actually sense. So I'm just using the risky command line parameter to see what's going on, and sometimes I manually just take a look at the flows, what's happening there. So yeah. This is one use case. Another use case, I want to like show you actually the machine learning approach. But as you can see, I just replanted the dataset contains 7 million entries and it's still training. So this is unfortunate. It's still training, but yeah, I would like to show you that at some point. And my last example is basically one of the most used example by myself at least. This is like the capture daemon or capture microservice. It connects to the distributor, nDPId of the daemon distributor, and gives you certain information. So you can basically say, I want to log every risky flow to syslog, or what is more important for myself is to dump risky flows to a pcap file, or for example, dump undetected flows to a file. This is like the most important feature basically for me, because everything I do with nDPI basically is required. So I need this feature to improve nDPI. And yeah, that's it. Any questions?